Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, previously I recorded around 40-45 lectures related to the subject Fundamentals of Mechanical Engineering and covered almost each and every topic related to the subject. But now I am bringing a new series which are basically based on the numerical problems and the questions which are very frequent in the examination. So, because students sometimes, those who believe in one day study, for them at least minimum these type of questions can be helpful. So, very frequently asked question from the unit 1 is to find out the support reactions for a beam. So, beam, we know what basically the beam is. Beam is a horizontal structural member which support transverse load. I am not going in detail of beam. If you want to learn about beam, you can go through the video related to the beam and support reactions. Okay. So, beam is a horizontal structural member to support transverse load. And what are the different type of transverse loads which generally a beam encounters? Point load on a certain point, uniformly distributed load which is spreaded with the uniform thickness, uniform load intensity at every point of the length over which it is spreaded, and uniformly varying load. So, here we are finding that this is the uniformly varying load. At a constant slope, it is increasing slowly and slowly, gradually and gradually it is increasing. Now, if you observe which type of beam it is basically a simply supported beam in which a load of uniformly varying nature, already told, it is starting from the 0 kilonewton per meter to 6 kilonewton per meter over a length of 12 meter. Okay, very simple question, but it can be a part of exam. So, which type of force system it is? For the two-dimensional force analysis, if I have to analyze this problem, then I have to deal with three equations: sigma fx equal to 0, sigma fy equal to 0, and sigma m equals to 0. Okay, sigma fx equal to 0 means algebraic sum of all the forces which are in x direction. Sigma fy equal to 0 means algebraic sum of all the forces acting in y direction. Sigma m equals to 0, moment about any point in the plane must be equal to 0. So, one by one I am applying these equations. So, here this is a simply supported beam. At this point, if I say this is the point A, this is the point B. Okay. At this point A, I found that there is a one reaction force, that is Ra. On the point B, there is another reaction force Rb. We are not observing any horizontal reaction force. Okay. If I consider these as a knife edge support, so Ra and Rb. So, do we find any horizontal force in the equation, in the diagram? No. So, this equation, there is no use of this equation, sigma fx equal to 0. Okay. If is there any horizontal or inclined force, then we can use that equation also in the questions will be coming where we will be using that. Now, sigma fy equal to 0. What are the forces in bi-direction? So, Ra, I will be taking it as a positive one, Ra, because it is upward plus y की direction में है. Second, I am observing Rb, that is also okay, Rb. What is the third force? This is the UVL. UVL, how to write this? If directly I go, I will be writing, if I am converting it into a single point load, then I will be writing half into 6 into 12 equal to 0. From where it is coming, half into 6 into 12, it is basically the area of the triangle which is the uniform varying load, which is representing the uniformly varying load. Why it is half into 6 into 12? तो थोड़ी देर के लिए assume this, if it is a rectangle of this nature, then area of this rectangle or the total load, how much it will be? So 6 kilonewton per meter is the intensity. It is spreaded over the 12 meters. So if it is a UDL, ऊपर वाला भी हिस्सा मैं काउंट कर लूं एंड नीचे वाला भी. Okay, so then it is a 6 into 12. But in our question, ये portion तो है नहीं. It is not the part of the question. So how much it is? It is the half of the area. So half into 6 into 12. Either by this way or directly, if there is a triangular load, uniformly varying load, then the area of the triangle we have to take. So half into 6 into 12. So it will be coming out what? RA plus RB equals to how much? So RA plus RB. Let me write the equation first, then we will be dealing with. Then the third equation. First equation, x वाला eliminate हो गया. Second, sigma Fy equal to 0, RA plus RB minus half into 6 into 12. Okay, third equation. Moment about any point. Moment about any point. Because of what? Because of the various forces. So how many forces are there? There are 3 forces we are observing in the question, 1, 2 and 3. So moment due to RA. RA. Moment is what? It is a force into perpendicular distance. But this force RA, कहाँ से पास हो रहा है? It is passing through the point A. So the perpendicular distance of RA from point A, how much it will be? It is 0. So there will be no moment due to RA about point A. Then I am coming to the second force, that is the RB. The perpendicular distance of RB from the point A, it is 12. So I can write here RB into 12. What will be the nature of the rotation? In this manner. So it is the anti-clockwise. So I can take it as a positive. Okay, RB into 12. Now what is the third force? The third force is half into 6 into 12. So first I will write the load, half into 6 into 12. Okay, load. Where it will be effective? Where it will be effective? So when I convert a uniformly varying triangular load in a single point load, it is effective at the point which is at 2L by 3 distance from the 0 intensity. Okay, again I am drawing here, if there is a triangular load, okay, if I have to convert this load in a single point load, so that arrow is the representation of the triangle. It will be where? It will be at 2L by 3. L is the total length over which it is increasing. So 2L by 3. Okay. So this complete load will be here, 2L by 3. So load is already there. The perpendicular distance कितना हो गया इसका? 2 into 12 by 3. 2 into 12 by 3. So I can write here 2 into 12 by 3. What will be the nature of rotation? It is clockwise. So if मैंने anti-clockwise को positive लिया था, so I am taking it as a negative, equals to 0. Any other force? Any other moment? No. Okay. So there are two equations, RA plus RB. Now I am writing these equations. RA plus RB minus how much it is? 36 equals to 0. This is the equation number 1. And second equation is 12 RB minus 36 into 8 equal to 0. So RB is coming out, 24 kilonewton, and RA definitely it will be equal to 12 kilonewton. In the question, in the answer segment, it is written as R2 and it is written as R1. I hope a very simple question. बिल्कुल clear है, कोई confusion नहीं, each and every point is clear. Now I am focusing another problem. Okay, find out support reactions for the given beam. Now the beam is full of different kind of loads. Okay, what is this type of load? This is UDL, spiral जो represent किया है. What is the intensity of this UDL? 20 kilonewton per meter. Okay, from A to B over the length of 0.5 meters. Then at point C, you can observe a couple system, okay, that is the 100 kilonewton meter. Okay. At point D, there is a 50 kilonewton load downward. E, that is the support, as at support at B, and 40 kilonewton F point पर एक हमारा load है. Okay, very good. The equation हमें बिल्कुल clearly लिख सकते हैं. Okay, what are the, which type of force system? It is non-concurrent coplanar force system. All the forces are lying in the same plane. So this is a coplanar force system. For a two-dimensional force analysis, again we have to deal with three equations. Sigma Fx equal to 0. Is there any application of this type of equation? I am not observing any horizontal or inclined force in the diagram. तो मैं इस equation को अभी hold करूंगा. There is no need of writing this equation. If we find any horizontal or inclined force in the system, then definitely we will use this. So I will be starting my question with the second equation of equilibrium, sigma Fy equal to 0. Now after doing the first question, now we are experts slightly. So what are the forces in bidirection? I am observing RB and RE. These are the two upward force. So I am writing RB plus RE. Then starting from here, A to B, there is a UDL. For dealing with UDL, UDL को कैसे deal करते हैं? If UDL is like this, W kilonewton per meter is the intensity over the length L. It is spreaded. For converting it into a single point load, what I will do? I will write that is W into L kilonewton. So W into L. So here W is how much? 20 kilonewton per meter. Length कितना है? 0.5 meter. So I am writing 20 into 0.5. 20 into 0.5. W into L. कोई इशू नहीं? क्या ये फोर्स है? No. It is a moment. यूनिट देख सकते हैं. It is a couple. 100 kilonewton meter. So will this be the part of this equation? Sigma Fy equal to 0? No. I am writing the equation for the forces, not for the moment or the couple. So now I am moving towards the next one. Downward. अच्छा, downward क्यों लिया? Obviously it is downward. So negative ले लिया उसको. Okay. Then here it is coming out, that is minus 50. Then RE already ले चुका हूँ. Then minus 40 equals to 0. This is the equation number 1. What can I write? 50, 40, 90 or 90 and 10, 100. So I can write RB plus RE minus 100 equal to 0. This is the equation number 1. कोई चीज मिस तो नहीं कर रहे? I hope all the things are included. Now I am writing the equation for the moment. Sigma m, I can choose any point. I can choose either the point A, B, C, D, E, F, G or any other point in the plane of the board. But conventionally, we prefer the point at which the supports are. Why? To eliminate one of the unknown. Because if I am writing the equation of moment about point B, तो इससे क्या फायदा मिलेगा? RB eliminate हो जाएगा. क्यों? Because the distance of RB from point B is 0. So the moment will be 0. So this particular RB की जो term होगी moment के लिए, that will be eliminated. Okay. So now I am writing the equation sigma mb equals to 0. Let me start the equation. What are the forces? Moment due to RB 0. Okay. Moment due to RE. I always suggest my students that whatever the loads आपने sigma fx and fy की equation में consider किए हैं, please take one by one each and every so that you are not missing even a single load. Okay. So RB I have taken RE. What is the perpendicular distance of RE from point B? 1, 2, 3 and 1.5. So how much is the perpendicular distance? 4.5. So RE into 4.5. What will be the tendency of rotation? Anti-clockwise. So I am taking it positive. Okay. Now the second, another load is, this is done. Now 20 into 0.5. तो मैंने इसको completely लिख दिया 20 into 0.5. That is the load. At what distance 20 into 0.5? So obviously that W into L कहाँ पर होता है? It is at the midway, midpoint, halfway. Okay, midpoint. तो distance कितनी हो जाएगी? It is here. So this distance, perpendicular distance, how much it will be? This is 0.5 into 2. Tendency of rotation, anti-clockwise. So this is also positive. Now I am coming to this 100 kilonewton meter. This is couple. Couple is a free vector. It is not associated with a point. Okay. So it is free at any point. Its nature and magnitude जैसा है as it is we have to take. So for point B also it will be taken as anti-clockwise. So plus 100. Okay. So 3 RB RE 20 into 0.5 100 kilonewton meter. Done. Now I am coming to the 50 kilonewton. What is the distance of 50 kilonewton from point B? So it is 1 plus 2 3 50 into 3 50 into 3. And what is the nature? कैसा होगा? Clockwise. Now I am coming to the 40. What is the distance of 40 kilonewton? 40 kilonewton. 1 plus 2, 3, 4.5 and 0.5. So it is 5 equal to 0. So here I can find out the equation. इसको solve कर सकते हैं and RB and RE find out कर सकते हैं. RE into 4.5 plus how much it will be? 0.5 into 0.5. So 0.25, 10. So I hope it is how much? It is 2.5 or anything else? 20 into 0.5 into 0.5. So it is 10, 5, 5.5. So it will be 2.5 plus 100, okay, plus 100 minus 150 plus 200. तो ये कितना हो गया? 350 equal to 0. By solving these two equations, we can find out what? So it is how much? It will be how much? We can find out. Can be? Yes. 350. So 250, 252.5 and 252.5 divided by 2.5. So we can get RE. You can solve it. Okay. And by putting the value of RE here, you can easily find out RB also. So by this way, we can find out the unknown reaction forces. So these are the two cases. First case was related to the UVL and what? UVL and simply supported beam. The second case is based on the overhanging beam because the sum of the part is not supported. Okay, AB and EG, that is in the air, so it is overhanging. In this, we discussed UDL, point moment, like this. Okay. Another question of similar nature you can take. So this is the question for your exercise. Answers are written over there. This is which type of beam? This is a cantilever beam. So for cantilever beam, you can solve. Here the support reactions and reactive moment are shown here. Okay. So you can easily find out if In case of any problem, definitely in the next lecture, I will be covering this question also. So thank you very much for watching the video. I hope the video is useful for you. Thank you very much. Thank you.